All right, hello everyone, and welcome back to the Math Puzzle Crash Course. I wanted to just briefly cover a topic that comes up every now and then, especially in some online forums, Facebook and so on, where we discuss some of the order of operations problems where, you got a problem with mixed operations that maybe has multiplication, addition, subtraction, division mixed together somehow. And I wanted to cover this topic of the obulus, which is a common division symbol that I know it's been used a lot here in North America. I believe it has other meanings in different areas. I think some parts in Northern Europe, I think it might actually represent subtraction, so it has a different meaning. But also historically, there's been some different interpretations. There's some controversy over the use and interpretation of the division symbol, which is known as the obelus. The symbol's represented, you can see that here with the horizontal line and the two dots, one above, one below. Some people refer to the dots as representing the numerator and denominator in a division. Many would recognize an equation like the following. If you have 45 divided by 9, it's pretty obvious that that's equal to 5. That's not controversial or open to any interpretation. But yeah, because we have 45 divided by 9, it's the same as writing 45 ninths. You can have the forward slash or the horizontal line, 45 over 9. And but if you look at a lot of educational interpretations in education mainly, and you try to enter some of these problems into a scientific calculator, like for example, we have a problem here, 3 times 5 divided by 10 times 3. So what's going to happen here is you're going to have, multiplication and division left to right per the order of operations. So 3 times 5 is 15, which I have highlighted in red. Then you would do division next. 15 divided by 10 is 1.5. 1.5 times 3 is 4.5. So that seems pretty normal, the way a lot of people do interpret the obulus. It means, when we're looking at it right here, it's 15 divided by 10. It's not 15 divided by 10 times 3, or it's not 15 divided by 30. However, if you look back to the book, there's a book, Deutsch, I hope I'm getting this right, Deutsch. Sounds a lot like Deutsch. Deutsch is a D, but it's Deutsch Algebra from Johann Rahn, which was written back in 1659. Um, the obulus appeared in the book, but had a different meaning than a lot of people interpret it today. I think in page 76 of that book, it's quoted quite a bit because it shows this problem, t divided by plus gg plus 1. I'm not sure I quite understand the plus sign here, but then you have equals, and then that's equal to plus t over gg plus 1. So you can see what happened here. This obulus was interpreted as meaning divide what's ever to the left by everything that's on the right. And some people today still interpret it that way. Another way to look at that interpretation is with an algebra example here, where you have a divided by b plus 1. Using that interpretation, it would mean a over the quantity b plus 1. Basically, same thing as putting parentheses around b plus 1, is how that would be looked at. And there are some other books that agree with Johann Rahn's use of the obulus. There's a Google search can find examples from a first book in algebra from Wallace Boyden that was written in 1895. If you use that interpretation of the obulus back in our original problem, and you're trying to hold to the order of operations at the same time, what you're going to end up with is basically 3 times 5 in the numerator divided by 10 times 3 in the denominator. So what you're going to end up there is a half. So your answer to that problem would be a half. And I have seen some people answer this very problem like that. But you could, here you can think of it here as 3 times 5 divided by 10 times 3 is half. But well, you normally would have parentheses around the 3 times 5. But most of your scientific calculators do not use that interpretation. You can see right here, this is a Windows 11 machine. Use the scientific calculator. The standard calculator is kind of hot garbage. A lot of people will use the standard calculator and get a wrong answer with mixed operations. So I don't want to go into that here. I have another video going in a lot more detail on calculators, but you can see here 3 times 5 divided by 10 times 3 comes out to 4.5. So they're really not using that older interpretation. So it comes down again to a question of convention and acceptance of convention. After all, the order of operations convention is a convention. It's not a law, and it's not really a rule as such. It's a convention. ISO, which is the International Organization for Standardization, has ISO as at 80,000-2 colon 2019, which discusses quantities and units for mathematics. And in the standard, they recommend only using the solidus or the fraction bar for division or the colon for ratios. It suggests the obulus should not be used for division due to the ambiguity of the convention for its use. So, it's also, like I mentioned before, it's also often forgotten that the order of operations convention is a convention. It's not really a rule or a law. But in most strict educational interpretations, in the order of operations, at least in North America anyhow, and probably elsewhere, the odulus is not interpreted as often as it in the way that it is in the Deutsch algebra or similar books. There is a well-known picture of a couple scientific calculators shown side by side, a couple Casio calculators where there's this famous viral problem that goes on. This picture, I believe, is from Quora, but you have this problem 6 divided by 2 times the quantity 1 plus 2, but there's no multiplication symbol. This one, we're often referring to this problem as using what's known as multiplication by juxtaposition, where you don't have an explicit multiplication symbol. But that's not even the half of it. I mean, whether or not you personally accept implicit multiplication or multiplication by juxtaposition as a valid convention. There's a lot of people disagree on that. Whether you do or not, that's not even the whole problem. The other issue is you have the obulus in here. So 6 divided by 2 times the quantity 1 plus 2, it's interpreted as 6 divided by 6 by one calculator, or as 6 divided by 2 quantity times 3, which ends up being 9 by the other. And as I mentioned, you could point out this multiplication by juxtaposition as the reason, but also it could have to do with how someone's interpreting the obulus. I'm not going to go into the implicit multiplication argument here. I'm pretty familiar with those. I mean, there's going to be comments about the distributed property or how A times B in parentheses can always be replaced by A with A times B with an explicit multiplication symbol. And some people will say, well, A times quantity B is also interchangeable with AB in parentheses and so on. So it can't really be both, but I can understand that it'd be great if everyone could agree 100% on a convention. The conventions really don't need to be joined together if parentheses are used to reduce any of that potential ambiguity or just explicitly call out, the multiplication and just avoid that whole controversy. But with the interpretations, the obulus parentheses could help in this case, where you'd have 3 times 5 divided by, and then in parentheses you could put 10 plus times 3, which could be looked at as zero point 0.5, or another way would be to add parentheses to come out with 4.5. Do the 3 times 5, um, and then divide 15 by 10, and then times by 3, and then you would have 4.5. So that's one way to avoid it. Now, I'm not saying anything regarding the order of operations convention. That's, pretty standard. You've got parentheses, exponents, multiplication, and division are equivalent, and they're one step. And then the fourth step is addition and subtraction, which, you can do left to right, backwards, forwards, whatever. Addition and subtraction you can do in any order. They're equal precedence. But what I'm referring to here is just to avoid any controversy over the obverse. you could use parentheses. So yeah, again here I'll go through it again. I just said it, but if we focus on the way the order of operations convention is generally taught in North America and elsewhere, you have PEMDAS and BODMAS. There are a couple common acronyms, but the structure is really simple. It's parentheses number one. Some people refer to those as brackets. The brackets would be the B term in BODMAS. You have exponents in PEMDAS, which is also orders, or I think powers of is referred to in BODMAS. And then for both of these acronyms, you have multiplication and division left to right. They're equal precedence. You just go left to right. And then you have addition and subtraction left to right as the fourth step. So yeah. So following the order of operations convention, there's no parentheses or exponents. So you'd start solving multiplication division left to right again, kind of like what we did before. You've got your 3 times 5, which is the 15. 15 divided by 10 is 1.5. Finally, multiplication is your next step. 1.5 times 3 is 4.5. So, yeah, I mean, the way I see it, with the order of operations convention, it consists of, really three operational steps. You have the exponents, which also square roots are involved in that too. Square roots, exponents. Number two, you have multiplication and division. And number three, addition and subtraction. The parentheses are just grouping symbols. So, if you also interpret the obulus as kind of a combination of the two. It is an operation, but it also kind of has depending on how you're interpreting it, it could have the equivalence of, adding parentheses. So it's kind of like an operation, and it also has an impact on grouping depending on how you interpret it. And again, it's a convention. It may not be as common today to see the obulus interpreted as it has been in older books, but it is good to know the history of that and the understanding of that. Um, yeah, and so arguing back and forth over implicit multiplication's priority or the use of the obulus is not exactly the same, but um, it's kind of like arguing against parentheses or brackets. I could just say that, hey, multiplication and division already have precedence over addition and subtraction, so just because you added parentheses around the addition is meaningless. But that'd be kind of dumb for me to make an argument like that. I'd be arguing against, an accepted convention. We've already got parentheses and brackets, as a pretty universal standard, so it'd be kind of silly to argue that. But anyhow, I just wanted to cover briefly some of the history behind the obelisk. A lot of you'll run into people who will say, "Oh man, why are you using that?" And some people are like confused as to, well, why would you say that? But there are some valid points behind it, and even ISO recommends really not using that as a symbol. So hopefully I'll try to point that out in more of these problems as I go through them. But I hope the video overall has been helpful, and if it was helpful for you, please consider liking, sharing, and even subscribing. We love the subscriptions. So thank you again, and have a great day, and see you in the next video.